Welcome to lecture 21 of financial management, and we are going to continue our discussion on the topic of capital budgeting. So previously we discussed different capital budgeting techniques. We have discovered NPV, payback period, discounted payback period, average accounting return, profitability index, and in last lecture we explored the idea of internal rate of return. I would like to have another example on IRR so that our concept can be deep rooted. Then we are going to discuss what are independent and mutually exclusive projects. And then lastly, we are going to see what are conventional and non-conventional cash flows. And once we have understood the idea of conventional and non-conventional cash flows, we will try to explore the last budgeting technique, which is MIRR, Modified Internal Rate of Return. We will see what is the issue with internal rate of return. That's why we have another technique which is called Modified Internal Rate of Return. So let's start with the example. So we need to find the IRR of following cash flows. If the required rate is 16%, then should we accept the project or not? Remember, the IRR decision rule is if the IRR is greater than, if the internal rate of return of the project is greater than the required return. So we require that the project should give us at least 16% of return. If the IRR is equal to or greater than 16%, the required rate of return, then we must accept the project. So if the IRR that we are going to find is greater than RRR, then we accept the project. In other case, we would reject the project. So we have this following cash flow. At year 0, our cash outflow would be minus 34,000. At year 1, our positive cash flow would be 16,000. Year 2, again plus 18,000. And year 3, the positive cash flow would be 15,000. So we have 3 years. We would have a positive cash flow for 3 years and a negative cash flow at time 0. So again, we know that there are two techniques to find IRR. First one is the internal rate of return, and the second one is the interpolation method. So first, again, we are going to solve this question to find the IRR of these cash flows using trial and error method, and then we are going to use the interpolation method. So starting with the trial and error method, you know that we first try a value of R, a discount rate. We find the NPV. If NPV is not 0, then we try another discount rate. Now, should we try a higher discount rate or lower discount rate would depend whether the NPV was positive or negative from our first trial. If it was positive, then we need to increase the discount rate, the R value. If it was negative, then we need to decrease the R value. So first, let's assume the discount rate of 10%. You can start at any point. You can assume 11 or 12 or 13, whatever you deem fit. We find the present value of cash inflow. Remember, our first cash inflow was 16,000. To find the present value, the formula is future value divided by 1 plus R raised to power n. For first cash flow, the cash flow is 16,000. 1 plus discount rate is 10%, so that would be 0.10 raised to power 1. Why? Because the first cash flow is received at the end of year 1. So we need to discount it for 1 year, for one time period. The second cash flow is 18,000 divided by again 1.1 raised to power 2, because the second cash flow, which is 18,000, we would receive this cash flow at the end of 2 years, plus the third cash flow, which is 15,000 divided by 1 plus R raised to power 3. Why 3? Because we are going to receive this 15,000 at the end of 3 years. So if we simplify, we would get this cash flow from this part of the equation we would get 14,876 from this part and 11,269 from this part of the equation. If we add them up, then our cash inflow from the previous cash flows that were given in the question would be 40,690. So our cash inflow is 4690. What is our cash outflow that had been given in previous slide? It was minus 34,000 or 35,000. The formula of NPV is present value of cash inflow. This is the present value of cash inflow. We have discounted all the cash inflows. Minus present value of cash outflow. We do not need to find the present value of 34,000 because it is already in the present form. So we get 6690. This is our NPV. Remember, IRR is the discount rate at which the value of R at which NPV is 0. So if we take a value of R, the discount rate, if we assume a value of R, that would turn this NPV into 0, then that discount rate would be considered our IRR. So we tried 10%, but the present value of cash inflow is greater than present value of cash outflow. We get positive NPV. Now if we need to have, if we want to have a value of R, the discount rate at which this NPV would be 0, then we need to increase it, right? Should we increase it or decrease it? The question is, should we assume a 20% or 5%? I mean, should we increase it or decrease it? Obviously, if we increase the denominator, the answer would decrease. So we rather increase the denominator. So in this case, rather than taking 10%, we should increase it. Whatever value you take would be your choice. You can either take 20 or 25 or 30 as next assumed value of R. I am going to take the value of 20 and then I am going to calculate NPV. Again, all the values are similar from the previous equation. We have just replaced 1.1 with 1.2, and that is because 1 plus 0.1 we had assumed 10% discount rate in previous equation, and in this equation we have assumed 20% discount rate. So it would be 1.2 rather than 1.1. If we simplify this, we get a present value of cash inflow of 34,513. This is the present value of cash inflow. We find the NPV, and NPV is this present value of cash inflow minus 34,000. The present value of cash inflow is 513. Now again this value is positive. We first tried 10%, it was 6690. We increased the denominator, so the answer should decrease. It had decreased, but we needed a value of 0, so we need to further increase it. We can either take 22, 23, 24. So again we will have to try. So let's see. I have taken, this is 25. I have assumed a 25 discount rate, 25% discount rate. And again I am going to calculate the present value of cash inflow. I have just replaced this part of the equation. Instead of taking 1.20, I have taken 1.25 because our discount rate is 25%. The present value of cash inflow is now 31,372. Now you would have noticed, if we find the NPV, the cash inflow, the present value of cash inflow is lesser than the present value of cash outflow. So the NPV turns out to be negative. At 20%, it was positive, slightly positive. At 25%, it is negative. So now we know at 20%, the value was 513. At 20%, it was 513. At 25%, it is minus 2628. So we know that 0 would lie somewhere here between 20 and 25, probably around 21 or 22. So again we need to try 21 or 20.5 or 22, so we'll have to keep on trying till we get the value of 0 or almost 0, because we are rounding off the decimal points. So I had tried different values and I get the answer of 20.97. So at 20.97, if we take the discount rate of 20.97, so this would be 1.2097. Again, all these values would be replaced. If you want to try, you can try it. You get almost 34,000. Present value of cash flow would be 34,000 if you try 1.2097, and the NPV would be 0. So the NPV, so we have find the IRR. The IRR is the discount rate at which NPV is 0. Using the trial and error method, we have found that 20.97% is the IRR value. Now you would have you have obviously understood that it is difficult to use trial and error method, in a sense that we have to use different discount rates. So rather than using trial and error method, there is another method that we can use to find IRR, and it is called interpolation. Now what do we do in interpolation is we find two values, two NPVs, two discount rates, and then we estimate the IRR. So let's look at the formula, although we have already seen it. IRR is equal to IL. The IL is the discount, the lower discount rate. Now, rather than saying it the lower discount rate, let's call it the discount rate at which NPV was positive, right? IH is the discount rate at which NPV was negative, minus again IL, NPVL. So this is the NPV at the discount rate of IL, again NPVL, low. This is the NPV at the discount rate of IH. So this had already been discussed. Let's see the steps. First, we find the discount rate at which NPV is positive. Remember, we used 10%, NPV was positive. Then we used 20%, NPV was positive. So we can take 10 or 20%. They both are fine because in both cases NPV was positive. Then we need to find the discount rate at which NPV was negative. So we used 25% at which NPV was negative. And then we used to use the interpolation formula. Now one thing, should we take 10% as IL or should we take 20%? Because in both cases NPV was positive, right? So because interpolation is an estimation method, you should keep the range of the window as close as possible. So instead of taking 10%, you should take 20%. So now you would be finding, the interpolation method would be finding the IRR between 20 and 25%. It would have more accuracy rather than finding the IRR between 10 and 25%, right? But in this case, I am going to do it using the 10%. I would suggest you do it at 20%, right? Replace 10 with 20 and see how your IRR turns out to be. At 20%, it would be more accurate. Okay. So IL, 10%, the lower interest rate at which NPV was positive. IH, the higher interest rate at which NPV was negative, was 25%. We minus the 10% discount rate. Now this is the NPV that we are going to take, the NPV that we found using IL. So at 10%, our NPV was 6690. So if you are going to solve it at 20%, then instead of taking 6690, you are going to take 513, right? Because that was the NPV at 20%. Okay, so the solution would be IRR is 0.2076 or 20.76%. Okay, so this was another example of IRR. I hope now the idea would be clear. Okay, so let's move towards our next topic, which is independent and mutually exclusive projects. So we have two different types of projects, one is called independent project and the second one is called mutually exclusive project. Now, what is independent project? Independent projects are the projects whose cash flows are independent of each other. So, for example, you have two projects. Project one is that you can either start an automobile business, and project two is that you can either start a transportation business, right? These two projects are independent of each other. You can start both these projects if you have enough cash flows, or you can start one of them. It doesn't mean that if you start automobile business, automobile manufacturing business, then you cannot start transportation business. For example, we have a firm which is called Daewoo. Now, Daewoo have both the automobile manufacturing business and as well as transportation business. So they manufacture the automobiles, and as well as they have they have a transportation business, right? The transportation passenger transportation buses that we have over here. So it means that if there are two projects where it is not necessary that if you are going to start one project, then you cannot start another project. In other words, you can start both the projects simultaneously, then that project would be called independent project, and their cash flows are independent of each other. Then there is a mutually exclusive project. It means that if one project is accepted, then other must be rejected. Okay, what this means is that you have a plot. Let's say you have a commercial plot. So you have two projects that you can start. Project one is to install a factory over the plot, the commercial plot, right? And project two is to build a commercial market or plaza kind of a thing, where you would rent out the shops. So you can either build a factory or a commercial plot or a commercial plaza. Let's just say the size of the plot is limited. It can either hold a factory or a commercial plaza, or let's just say the law restricts you either to have a factory on a plot or to have a commercial shops. So whatever the case may be, either it is the law restricting you, or it is the physical restrictions that are there. In both those cases, you are either going to choose project A or project B, project 1 or project 2. So now these two projects are not independent. That means if one project is accepted, the other would have to be rejected. So their cash flows are not independent. So this is the idea of independent and mutually exclusive project. And in next video, we are going to discuss the conventional and non-conventional cash flows. And once we have understood the idea of conventional and non-conventional cash flows, we are going to see what issue non-conventional cash flows generate towards the IRR, and then the IRR becomes non-conclusive. So we are going to use another technique which would be modified internal rate of return.